Hey guys, this is Mr. H. I'm back with another video on doing inverse functions, but this time I wanted to show you how you could use the free online graphing calculator DESMOS to check your inverses to make sure that they're actually correct. Um, so I am going to start by doing number 34. So I've got g of x equals x minus 1 to the third power plus 2, and I'm going to come up with the inverse. The way that I've been teaching this is if you understand PEMDAS and you understand inverses, it's a fairly straightforward process to come up with the inverse function. So the very first thing I'm doing is I'm going to use PEMDAS, and it tells me that the first thing that I'm doing is subtracting 1. So I'm subtracting 1 from x. Next thing that I'm doing is I am raising that difference to the third power. And then the last thing I'm doing is I am adding 2. So I've done this and this. All right, so now what I'm going to do is I'm going to do the inverse. So the inverse of adding 2 is subtracting 2. The inverse of raising something to the third power is taking the third root or raising it to the 1/3 power. Either one of these will work. And then the final thing that I'm going to do is I'm going to add 1. Now I'm going to do this operation first. I'm going to do this operation second, and I'm going to do this operation third. Now I know I'm going to write this g of a negative 1 of x. This is the inverse. I know I'm going to have x on this side. So now all I'm going to do is I'm going to do all 3 of these steps, and that's going to be my inverse. So the very first thing I'm going to do is subtract 2. Let's make this red. So I'm going to subtract 2. Done. And then I'm going to take the cube root of the difference. So I'm going to take the cube root. That's this. And then I'm just going to add 1. I add 1. And that's the inverse. We're done. Pretty straightforward. Now, I'm going to check these two to see, in fact, if they are inverses. So now I'm going to DESMOS. And I've already got something in here, but I'm going to back all of this out. So the very first thing I'm going to do is I'm going to enter the original function, x minus 1 raised to the third power plus 2. Okay, now that's what the function looks like. I don't want that one. And now I'm going to take this one and I'm going to enter the inverse. So this is the cube root of x minus 2. Now I'm going to use a rational exponent instead. So this is going to be x minus 2 parentheses raised to the 1/3 power. And then I add 1 to it. And notice, so the red one, this is the function. The blue one is the inverse function. And the green one, that's the graph of taking the inverse and inputting it into the original function. And it traces out the y equals x line. Now, whenever you take the inverse of a function, if they are in fact inverses, you should always get y equals x, and that's what I got here. So that's my confirmation that these two are in fact inverses of each other. Okay, so whenever you take the inverse and you input it into the original function, you should get y equals x. It should be equal to x, which is what this is saying. So that's all good. So then let's go, and I am going to do another question. Let's see here. I'm going to clear the ink. Let's see. Let's do 32. So 32 is f of x is equal to 3 minus 2x to the 5th power. Now, so I'm going to do PEMDAS. And according to PEMDAS, the very first thing that I do is I'm raising x to the 5th power. Second thing that I do is I'm multiplying that by a negative. So I'm going to say, let's say times, that's a time symbol. Or let me just do it this way. Let's put a little dot. And then we're going to say we're multiplying by a -2. And then the third thing that I'm doing is I am adding a +3. So those are the three things that, according to PEMDAS, we are doing. Now we are going to do the inverses. So the inverse of adding 3 is subtracting 3. The inverse of multiplying by a -2 is dividing by a -2. The inverse of raising something to the 5th power is taking the 5th root of that. And we're going to do this first, we're going to do this second, and we're going to do this third. So down here, we're going to have the inverse. And we know that we have to start with x on this side. So I am going to subtract 3 from x. That's the first thing I do. Then I'm going to divide by a -2. So I divide by a -2. And then the last thing that I'm going to do is take the 5th root. So I'm going to take the 5th root of that. And that is my, that's my inverse. Now I'm going to clean it up or simplify it a little bit. You don't have to do this, but I am going to make this a +3 minus x over 2. Basically, I just took the negative and I multiplied the x by that and the -3, and I got that. So these are basically the same. You can enter any one. So now I'm going to go back to DESMOS. I am going to take the original function and I'm going to enter that. So it was 3 minus 2x to the 5th power. That's the original. And then I am going to take the inverse, which I said was, so I'm going to use a rational exponent. So this is going to be 3 minus x on top. On the bottom is going to be a +2. We close the parentheses and we raise it to the 1/5 power. That's the same thing as taking the 5th. Whoops, that's not quite what I wanted to do. So I want to take 1/5. All right, so now, if you look at these two functions, the red one here, the blue one here, but most importantly, when I take the inverse and I input it into f of x, I get the green y equals x. You can see that this is y equals x. It's going through the origin, it's going through the 0.22, it's going through the 0.44, it's going through the point a -2, a -2. So that is indeed the y equals x line. So the fact that when I take the inverse of the function and input it into the original function, I get this graph is confirmation that these two, in fact, are inverses. So that's one way to check it. To me, that's a good way to check your algebra. All right, I think I'll try one more. So let's go back to my iPad real quick. And let's see here. Which one am I going to try now? Let's try number 30. So number 30 is f of x equals 5x minus 5 over 4. This is a linear function, and so the inverse should be a linear function. And we're going to find it and we're going to check it to make sure it's correct. So I'm going to use PEMDAS. First thing that we're doing to x is we're multiplying it by 5. Next thing that we're doing is we're subtracting 5. So we did this first, we did this second, and then the third thing that we're going to do is we're going to divide by 4. Now we're going to take the inverses. So the inverse of dividing by 4 is multiplying by 4. The inverse of subtracting 5 is adding 5. The inverse of multiplying by 5 is dividing by 5. And here's the order. We're going to do these things. We're going to do 1. We're going to do that first, do that second, do that third. Excuse me. And so our or inverse is going to be x, and then we're just going to do these things to it. So the very first thing that we're going to do is multiply by 4. Okay, that's done. Then I'm going to add 5. And then I'm going to divide by 5. And that's my inverse function. So if I go to DESMOS, we can check this. Very first thing I'm going to do is get rid of this, and I'm going to put in a stacked fraction, 5x minus 5 over 4. That's the original function. And now I'm going to put in the inverse. It's 4x plus 5 over 5. And you can see again, you've got two linear functions. And the most important thing that you should see is that, again, we have that green line that's going through 2, 2, 0, 0, a negative 2, 2, a negative 4, 4. So this is, in fact, the y equals x graph. That's what you should get when you take the inverse and input it into the original function. Or, let me see, we can do it this way. We can do g of f of x, and that'll give you the same thing. I'm going to take this one out. So you can see, I wish I could change the color. How do I change the color? How do I change the color? I don't know how to do that. How do you change the color? How do you change the, oh, okay, I'll make it purple. There we go. All right, so we're done. All right, so I made this purple. So you can see, it doesn't matter which way you go. Either way, and it shouldn't matter because they're inverses. So it doesn't matter which one goes inside, which one goes outside. They still should give you the y equals x line. So I can take this one off and I could do this one and it's still the same thing. So now I just showed you how you can use DESMOS to check your inverse functions. So if you have multiple choice questions, you could just find the ones that create the y equals x line. If you're having to come up with the function, inverse function algebraically, you can always use this to check it, which I would definitely recommend. But I'm hopeful that this has been helpful to you. I am going to sign off here. Let's see. And let me know in the comments if you have any questions. All right.